Good afternoon, everyone. Sorry to interrupt these guys. They actually were giving really nice talks. The shorts was a great idea, I think. And if you want to ask them more questions, please do. But we're going to do the next session now. So if you could take that outside, that would be fine, obviously. This is also an experiment. And I'm not quite sure if I'm meeting the experimental constraints, what we're doing here. So I proposed this as a non-technical session, and it got accepted. So now we're going to tell you what it's about. The abstract was, the blurb, as it was called, was on the SIGCOMM web pages. So you should have been able to see what this is about. So I'm John Crowcroft, and I am a professor of computer science in the University of Cambridge. I also work in the Alan Turing Institute, which is a national UK AI institute, for the last 10 years. So I am now actually, I think, an AI expert. So I do communications for like 45 years and AI for 10 years. And I feel like I've kind of done a second PhD in the last 10 years. So the title of this session is Scaling Science Like Systems. And then the kind of joke here was about rock, paper, scissors, which is the children's game, where you try and see who wins. You don't know what somebody's going to pull out as a, paper or scissors or a rock, and then you have this race, and then somebody wins. And there was, obviously there's this other saying of between a rock and a hard place. And what I'm alluding to here is basically the problem that we are facing in science today of the pace and scale of work. And this is, it really is a really huge problem. And we've seen this in communications a little bit, but let's go to the other world I work in AI. And we've had many papers here that are AI plus communications, whether it's AI for systems and networks or networks for AI. So there's always a bit of networks in there because this is SIGCOMM, hey, not NeurIPS. But if you look at the top 3 AI conferences in the world, let's just say NeurIPS, for example, we're looking at a publication rate from single conferences of 10,000 papers a year. And actually, one of the conferences just had a double from last year. So they're literally heading for 20,000. So why is that an issue? Well, I mean, I would just propose that no human could possibly read more than a very small fraction of those. So your awareness of what's going on in a community is very, very little. If there was something really significant in those 10,000 or 20,000 papers across 1 year in all the AI conferences this year will be 30,000. If there was an amazing paper in there, nobody will notice it with almost 100% probability. Just take LLMs. This is not to be rude about LLMs, but they've been around since the original Attention is All You Need paper is now 9 years ago, I think. And there have been 50,000 publications on LLMs since then, at least, and this was like a year ago when I did a count. So if you were writing a PhD dissertation on large language models, or transformers, or whatever you want, or foundation model AI, your bibliography would exceed the word count for our university limit on how many words before you've written anything. But you probably have died of old age before you actually read all the papers that you'd have to read to do a survey. So this is clearly a problem just in the domain of computer science and computer engineering in the AI world. And of course, in systems and networks, we've seen a slower but still an increase. There are lots of reasons I'm going to mention, which are definitely not all bad. This is not necessarily a bad thing. Another area where industry is more guilty, that's not the right word, but has a similar problem is in patents, and there are really gigantic number of patents. And one of the most ridiculous things I've seen is the US was saying the problem with competing with China is that the companies like Tencent and Alibaba and Huawei and so on are publishing so many patents, so many more than America. And that's a really strange way of measuring innovation. I mean, it's like, did they make more new things? Probably not. And in fact, if you go back in time in communications to when Europe dominated cellular, Nokia and Ericsson were certainly publishing huge numbers of patents, but that doesn't necessarily mean they were making lots of new things. So it's kind of interesting problem space, and I'm going to say, the word metric here is that we're measuring the wrong things. And another area is in software releases. And so, for example, if you look at open source archives, obviously GitHub being the kind of primary one out there, but there are others. There are really very large numbers of open source projects, and they have the usual distribution, like all these things, where there are a small number of popular ones and a really large number of ones that may be looked at by between 0 and 1 people. I mean, clearly the average number of readers for 50,000 LLM papers is probably 0. I mean, not that average is a good measure, again. So there are a number of reasons for all of this, and the top 3 here are supposed to be sort of positive things. There are more scientists in the world. We are actually developing the world, and it is clear from the statistics from the beginning of SIGCOMM, for example, that China is really accelerating contributions in a real sense. You know, with no change in what you think of quality of work, there are more contributions. So there are additional people doing the work. And this has been true in India, but in different areas. And we will see the same rise from African and South American contributions as well, and no doubt. So there's potentially, in some of the areas we're talking about, there's also potentially more resources, more money. Of course, there's kind of a zero-sum game here, so maybe it's coming out of doing other things. That's interesting. And maybe there are really more problems to solve. You know, maybe we're looking at problems not just purely at scale, which we hear about quite a lot in the SIGCOMM community, but actually in the number of problems that are arising. There's always the heterogeneity of the world. You have to deal with many different kinds of problems. So those are kind of plus points. You know, they're real, and we shouldn't be sort of thinking of ways to solve those things. They seem like, to me, to be quite good. On the other side of the equation, you know, there may be problems like what we call dicing and slicing, or minimum publishable unit, that people are getting really good at turning their work into a larger number of smaller pieces of work. And I think that is a thing. I don't think it's terribly true of papers being or accepted at SIGCOMM, but I think it may be true in other domains that the work is a wafer-thin increment over previous work. Not, again, a reflection of quality. It's just that people have kind of figured out this is the next publication in the sequence of work. There's also, you know, what the impact of the work is. You know, the impact of, again, I don't want to be negative about LLMs, but the impact of LLMs so far has been to consume a large amount of electricity. There may be some other impacts, and certainly impressed a lot of politicians and some venture capitalists, which is interesting. One of the things I found a little bit troubling in the AI world compared with our world is the lack of artifact evaluation. So in systems and networks, most of our conferences and some other venues are actually rewarding people that don't just submit the paper, but say, here's the code, here's the data, if it's not private or confidential, insofar as you can, and then actually it gets evaluated and you get a badge or even 2. I think Usenix were the first people to do this generally across the board, and that gave you a high assurance that there was reality there, but it also acts as a filter for people doing things that are vaporware. And I found that to be very, very good. Obviously, in some cases, there's commercial confidential reasons why people aren't able to publish that level of detail. But on the other hand, we kind of do believe that you know, Google Gemini actually is there because you can use it and you can see it exists, and they tell you a bit about how it works, and you go, oh, okay, I kind of believe that. And you know, there were partnerships between academia and industry that work pretty well. On the other hand, we have the rise of the, so we have in the AI world, there's not much artifact evaluation. And in fact, it's unsurprising. How would you evaluate the artifacts associated with 20,000 papers in a year, where each of those needs probably 2 or 3 PhD students to spend probably 2 or 3 months. So one of my students did a couple of artifact evaluation committees this year, and that was the kind of level of commitment he put in. It was incredibly useful for him, but are there enough people to do that? And I'll get on to, you know, maybe there's a kind of congestion control mechanism in there that could be applied that might work, a sort of matching of the input and output somehow, which works for submitting papers and reviewing, and could work for submitting papers with artifacts and doing artifact evaluation. And I think that would potentially lead to a balanced system, balanced workload between input and output, if you like. And then we have the problem of a significant problem of deepfake papers, and a number of other problems. But you know, we do see papers that are clearly largely auto-generated, and we probably have, papers have been published that nobody noticed that yet. Is it actually a problem? I mean, in some senses, this could be fear of missing out. You know, maybe I'm sitting here going, well, those NeurIPS papers are getting in, and maybe I'm upset that I haven't had, 10,000 papers accepted NeurIPS or 10. I think I have 2. But on the other hand, there's another interesting thing, which is some people have proposed the use of AI to help with accelerating the processes, the scientific publication process, communication process. So can we use LLMs, for example, as part of reviewing? And I think as long as there's some human in the loop somewhere, that's okay. I have a problem with the nature of science. Science comes from a word meaning human knowledge, effectively. That's where it's philosophically from. And if all the things that are learned by machines, then that's not human knowledge. And there are other interesting problems there, which we can get onto in discussion. But if a large amount of science is automated and known only to the machines that do that automation, there's not only the lack of transparency about it and the risk that if the machines break or are stolen or disappear, we lose that knowledge. There's also an ownership question. The people that own the machine that did that discovery could be have a monopoly over real fundamental knowledge, which is kind of interesting. This already occurred. It occurred in proof assistant, for example. The 4-color map theorem was proved by computer program. I was at the Académie des Sciences in France when they did a presentation about this, and a mathematician with a very, very long gray beard, he said, "How do you know your computer was not wrong?" And the presenter said, "How do you know your brain was not wrong when you did a human proof?" But there's that avoided the actual other question, which is who owns the intellectual thing behind that when that happened, which is kind of interesting. Oh, the answer, by the way, the 4-color map problem was the code was written in 3 different languages and tested with 3 different software verification tools as well. That's pretty cool, and nobody's ever done that to a mathematician, to my knowledge. So AI might help with the review processes. It might help speed them up. There's a paper in Nature recently by some colleagues of mine, which you can look up, that suggests that it can be good and bad. In my view, we've used this in teaching in Cambridge. We have people submit work, we use an LLM to review it, and we have a human sit down with the student who revises their work to meet to show they understood what was happening, so they did do their work, not use an LLM to regenerate new version of the work, and to show the teacher how far they're going. That seemed to work really well. So maybe there is a role here to have some sort of technology, but we can have a discussion. We wrote a thing several years ago. This was Nick McKeown, Keshav, and me wrote a thing that was in CACM about scaling the academic publication process to internet scale. And this was actually something that effectively is happening in NeurIPS, which is you're not really supposed to submit anything unless you also are part of the open review process they have. So you kind of have almost like a token system where you get tokens for being a reviewer, and then they get enough of them, you can submit papers. So this is an impedance input-output balance process, which I alluded to. And I think that in the open review in NeurIPS, I think it's actually working. I claim it's not too bad. I'm currently looking at open reviews I've just got for a submission, and they're pretty good, actually. And then there's a discussion process, and I think it's quite positive. So I think there's another role in artifact evaluation. I have not seen this suggested, but perhaps, given we have Copilot and other tools like that, perhaps if we did want to scale up artifact evaluation, we could use LLMs to do that artifact evaluation assistance as well. So we should be able to run things automatically and check the output corresponds to what the paper says, and that might help with acting as a filter for people submitting things that don't have artifacts or how they're ranked or whatever. So that's kind of the background to all of this. I mean, I would say that we in computer science and networks and systems, we're not the only game in town. There are other systems at scale. For example, some of my colleagues in the Turing Institute in London worked on the Large Hadron Collider. The Large Hadron Collider was used to discover Higgs boson. After 30 years of theory, they proved the existence of a particle at a given energy level. There's one paper after $3 billion of expenditure, but boy, is it a cool paper. And it was verified. In fact, they had 2 separate groups which were not told about each other, and then they both submitted the results in parallel, and they had the same result for the energy level. They found it, and then they published, which was also interesting. That's an extreme version of artifact evaluation. Another example is the Human Genome Project. Human Genome Project, Sequence the Human Genome. There were 2 projects. There was a competition between an open and a closed system between the US and Europe, and they got the same results. This was very cool too, and in a way that gave you verification that what was going on was good science at really large scale. And they didn't publish huge numbers of papers. They did produce an artifact which you can go and use to design drugs and test systems and so on. So I think that was pretty interesting. Okay, so I've got some questions, that I was going to ask my esteemed colleagues over here, and anyone in the audience can now stand up and also answer these questions, or ask a question, is there really a scale problem with science? Do we think it's a problem? Do we have, particularly in the SIGCOMM community, a problem? Do we know our colleagues in other branches of our domain have a problem? One of the things I would say is, can we have better metrics for what I'm going to call quality of science? And I know QoS is a word that a lot of people would laugh at if they hear it from me, but I'm going to use QoS as a quality of science metric. And I think it would be interesting to say, not that we stop people publishing yet another RDMA paper, not at all. They're really useful incremental work. But we say, the really important papers are over here if you want to know the big advance this year. What's the equivalent of the Attention is All You Need paper for 2025, for example? And there's this, as we use more technology to do all these things, how do we keep the human scientists in the loop? And then the last question I already forward referenced is, what do we do about the ownership of the science when it's semi-automated or fully automated? Those are my 4 questions. You can ask another one, or you can answer those. So who wants to go first? Christoph, over there.
Yeah, the first question is, did we just create the system and the loop in which we are today by pushing people to do too many implementation and system papers where, and maybe the idea papers have disappeared, okay? I don't know. I mean, should we come back to have specific conference that publish papers that are about ideas? I mean, I remember Nick is always telling me, Nick McKeown was telling me a long time ago that in a SIGCOMM paper there should be 3 components, which is a good methodology or a good idea, something new. It should be well validated, and the writing should be good. So the writing is solved by LLMs. We don't have this problem anymore. But, I mean, when you look at many of the implementation paper, we just describe something that we have implemented, and as you say, with the mass of things that we implement, that we try in different systems, maybe the idea paper are swallowed or disappear under, and we don't see them. I agree with you that there are so many papers we cannot read everything, and so maybe we need to come back, encourage people to publish paper like Walter did with his self-similarity paper, okay? I mean, that there was an idea, there was a validation. He could have done it with 10,000 machines at the time, but nobody asked him. And I think we probably need to come back to that.
Okay, thank you. I think when John asked me here to sort of make some comments, I sort of thought, oh, I have an agenda that I want to present to you, and that is sort of to show my age. And this example comes from John. 2000, around 2000, our community went through something similar when we had these tons of papers in SIGCOMM that had to do with NS simulations. Some of you may remember. There was a time where NS1 and then NS2 came along, and pretty much every other paper that was submitted to SIGCOMM had an NS simulation. What did our community do when they realized that there is this wave or deluge of NS simulation papers coming? It took maybe, I don't know, 2-3 years, relatively quickly, and it stopped. And the community did it by raising the bar, raising the standards, meaning saying a paper that simply reports about a simulation result with some topology, some traffic, and some results is not good enough. There needs to be more in terms of knowledge, understanding of what does it contribute to science. So now let's go back, let's go forward 25 years, or 25 years today. SIGCOMM is innovated by papers on AI for networking, for example. So any paper on AI. These papers, report about some model that has been developed for some problem based on some training data, using some model, and the end result of the paper is this model performs great, amazing. That's the end of the story. I think we are now at a time where, as a community, we have to raise the standard and say, this is not enough. A paper that only does that, in general, should be not accepted. And we have to set the standards by saying, in order for us to take this more serious and look at this paper in a way that maybe it gets towards accepted, is the paper has to answer 3 questions. Why does the model work? How does the model work? And when does it not work? If you cannot tell me those answers, the paper shouldn't be accepted. So I paint a little bit of a black and white world here, but in general, that should eliminate the paper from the process. That will be a clear way to prevent this deluge of papers from increasing in the future. But I don't know how to get there. But I think the community should think about this past experience in NS simulation. And I think John has this other example of ad hoc networks that had a similar experience. And the community reacted by raising the bar. So I think we are in a similar time where it's up to us to set and raise the bar in order to make sure that we are not innovated by papers that don't contribute to knowledge or science. So that's my...
So I have one comment on this, I think, which is, and then I'm going to try and change direction a little bit, if I may. Actually, hearing you speak about this, Walter, it reminds me of when students, I think a lot of us give public talks, or talks of any kind. There's know your audience, and all of those things matter. But I think fundamentally there's an element of you focus on what the audience needs to know, not what you did. And I think there's a knowledge building that you're embedding in this comment that you're making of raising the bar is like, I need to know, I don't want to know how you succeeded. There's an element of what I really benefit from is knowing something I didn't know before. I think there's still a scale problem there that needs to be addressed when we talk about the numbers that John just presented a moment ago. And honestly, I don't have answers, but let me, and this is where I change direction a little bit and I'll try and be fast. 2 anecdotes to describe something that I worry about, one of which maybe we don't need to worry about, one of which I hope has a solution. And I'll try and be, so my father died 20 years ago of pancreatic cancer. When we went to get him treatment, it was at the country's foremost cancer treatment center, 13 floors dedicated to nothing but, an oncologist with, 22 letters behind the name. And the oncologist said something really interesting, is, your father has a very rare cancer. If in this big hospital we get more than 3 or 4 cases a year, it's a bad year. Oddly enough, all of the knowledge that exists, this is a couple of decades ago, is written in Mandarin. And what? Yes, and interestingly enough, similarly, it's all in China, of course, because that's prevalence of digestive cancers. Similarly, in Mandarin, there's virtually nothing written about breast cancer. All of that is written in English and European languages because they don't see it. So when we talk about scale and fear of missing out and partitioning, one of the things that worries me is what if we miss something important? And maybe it's true that we see some partitioning. Maybe that's okay for a little while, because I have to believe that if somebody writing in Mandarin came up with a cure for a pancreatic cancer, that the rest of the world would know about it if it was important enough. There's an element of faith in that. I don't know if it's true, but I hope that gives some comfort. There is one thing, however, in the shorter term that makes me worry a lot. So let me try an exercise here, especially with the students. How many students have used Google Scholar to find information in the last, I don't know, 3 months, 6 months? Raise your hands. Great. How many of you have only used Google Scholar in the last 3 months, 6 months? And I'm including Google search in that, right? Because they connect together. Have you used any means other than, if you don't know where to look, is there any source other than Google Scholar? Wow. Then I want to know how you're searching for things, because I'm not sure many of us know where to go except to go to Google Scholar. And here's the question. What happens when Google decides to shut down Scholar? What's the alternative? How do people find things? And I don't know the answer to that question. Maybe it's DLBP because it's still around. Maybe we go back to CiteSeer. Andrew reminded me earlier that CiteSeer was really good at giving context to things, finding like it had a similarity index, you have merit or not. But I think that is a real risk to our community at the current scale, is it's a single point of failure.
I was going to mention something. Andrew Moore, who's my co-instigator of this partly, had some suggestions for helping out with the metrics for the quality of work. But sometimes these are problematic because they may only work after the event. But that still may be useful. We could use some kind of information theoretic, kind of model of what's in a paper and figure out its complexity in some sense, like Shannon or whatever. And it kind of links up with my idea that if you have artifacts associated with it, my examples of the Large Hadron Collider had Higgs boson, was a real particle, and then you've been reproduced as a result. And the human genome had 2 projects that sequence human, and there's an artifact, there's a real thing there. But even just looking at the papers, they're incredibly dense in information. They also have the craziest list of authors, 5,000 authors, not just 50. But we could also look at, and this is problematic, citation counts doesn't work, but if you take all the papers in a given subject domain, you can find the betweenness centrality of a paper in the citation graph, for example, and that tells you this was a really important paper. And you can look at the evolution of centrality in the citation graph over time, and it tells you a topic is important. And actually, Gareth Tyson and some others did this for a whole bunch of SIGCOMM papers and Infocom papers over 50 years, and you're able to see topics come and go and areas be important or not important and so on. And I wonder if things like that would help sort of navigate things. And I think one of the things I'm trying to avoid is suggesting that we, rate limit how much work people do. If people want to do lots of small steps and work, that actually means it's more likely to be verified. And it will be more likely to be comparable with other things. We just need ways to be able to explore all that information. And one of the things I put in the proposal for this session was some references to non-European historical science. So when you look at the history of the invention of zero, and you look at early gunpowder, these are India, Persia, and China, for example, and they had people that were what we in Europe would call a Renaissance person who knew all of the science at the time, the kind of equivalent of, let's say, I'm not going to be parochial and say Newton, I'll say Leibniz. But in some sense, it's really important that there are some people that have that grasp and cross-domain, because new things happen when you cross domains, when you mix things. Like we're having all these cool papers here about what do you do to scale up a data center to manage what's happening from training large language models. It may be we don't think much of the LLM at all, but it doesn't matter. It's really interesting what crazy things people are doing, which is really cool. Some of the things they're doing look like things from other domains, but a lot of people won't notice that because there's too much stuff to navigate. So being able to navigate the information, for me, and the novelty and where the important stuff is how do we scale that up as part of this space, which I'm trying to avoid being negative about it. It should be a good thing, but we also do need in the process to avoid a creeping increase in problems. So one of the things that happens when you build an internet scale system is you start out trusting everyone, And when you get past the first 150 sites on the internet, you discover the 151st site had somebody who was untrustworthy. By the time you get to a few million, you start to be dominated by untrustworthiness. So online payment systems, for example, many fail because the fraud level grew faster than the profit. So then you need to create mechanisms for that. So I would claim that if we want to keep growing science and we want to use internet scale techniques, some of those will have to be looking at eliminating stuff that's creeping in at the bottom end, and we could dominate. The noise floor would come up above the sea level and we'd be in big trouble. Sorry, that was a mixed metaphor. Anyway, any more input from you out there would be very welcome. If you've got any thoughts on this, I think it's sort of supposed to be a fun topic. You know, think about what you might use from things you use in communication systems, and how would they apply in the whole of science in the world? Do you have a kind of leap of ideas across the analogy, metaphor, reasoning by those processes? I think might be a fun exercise. And this is meant to be a non-technical session, right? So you can't be wrong, kind of.
Hello. Yep, over here. Thanks for the very interesting conversation. Sure, I'm appreciating this very much. But I have a little bit of a provocation for you, and I'm interested in your answer. So we're talking about the problem with the large amounts of papers that are flooding our conferences, and the strain that it poses on peer review, and metrics that we could change to address this, and token mechanisms. But one thing that I feel is a bit ignored is the central metric that is behind all of this, which is that to have a career in science, you are judged by your publication count and your paper count. And as a PhD student, I could have just written one single, very concise, very well thought out thesis across my 5 years, but instead I had to write a large number of papers that somebody had to review, and I think this is common for all my colleagues here. So is there a way in which we change the way scientists are evaluated, and this then turns into a change in how the publication system works? Thank you.
Does anyone want to reply to that? Because I'm going to provoke back. I mean, I've said this to a number of friends and colleagues in the room. As a student, I will say, I would say that may be a characterization of an academic career. I would not say that that is endemic in science. So I think there are many ways to contribute to the scientific endeavor. I find there are people I've met in my life, in our domain, outside of our domain. The way that they advance the human body of knowledge is extraordinary. It's not always about writing papers. Sometimes it's about writing code. Sometimes it's about showing up and making a comment. Some people have PhDs and many people don't. So I think the idea that we give to students that your career only is about publishing all kinds of very high quality papers, and very many of them, and you have to, do whatever you need to do to make it to the next phase. But that kind of a career to help and contribute to science is not the only one, okay? It may not be the answer that you're looking for. Yes, it's flawed. We all know it. There are things we want to change, and we try to improve, and we come back to this in cycles, as John alluded to. But make no mistake, there are many, many ways to contribute to the body of knowledge. Yeah.
That's BS. I mean, fundamentally, you're right. But the fact is that every time I am in a meeting on a PNT, Promotion and Tenure Committee, it's pathetically what you look at is the number of papers that you have, the citation that you have is a function of the number of papers that you have. We still, I think it was until maybe 3 years or 4 years ago, we still would send Patterson's note about code is a contribution to make sure that the committee upstream will get the idea. So I think we do have a problem. I think the comment is right.
Agreed. We have a problem in the academic line, 100%. I agree with you. The point is
There's a really nice industry version of this, and I was on the advisory board for Microsoft Research, and one of the group there did an evaluation of all the software engineers who worked on everything to do with Windows and Office for decades, and they wanted to look at could they find a metric for hiring and firing that would be, a sorting metric. And a metric. So, and it turned out that people that submitted more code on some project would submit less code than another, but they'd have more bugs, and the other people would have less code and less bugs. And it was like there were at least two dimensions, and there was no way to order people. It was like, what did you want? Did you want more lines of code and more functionality? But did it matter there were more bugs? And you might laugh and say, Microsoft, you didn't care about bugs, but everyone was like that. Everyone's move fast and break things. But the point was you couldn't find it, and maybe that's also true, that we're doing a crazy thing, which is we're just saying how many papers you've got. But what we should be doing is saying how many right and wrong papers have you got, and how many right and wrong papers a year are you doing, and how many projects are you proposing that get rejected because maybe they're good as well. So we could actually balance it. The other thing is we should definitely have negative citations. My two highest cited papers are wrong, and I have no mechanism to get the 4,000 cites to go to zero. People will still cite them and go, this paper did this. And I'm like, it should be, after other papers said this algorithm is literally completely wrong. That should go to zero in 1 year, right? It should be like these congestion control mechanisms that remove your capacity, to drop your capacity immediately. Why is that not there, right? Because then an H-index would also work properly. It would not go up forever, which is obviously nonsense. So I think there's definitely, so there's an industry version of the academic problem too, that people like to do 360-degree reviews of all the team, and everyone's got to be either negative or positive. That's slightly better than everyone has to be positive. But on the other hand, if you're some really good lab and everyone's good anyway, why are you doing that? So there are all kinds of questions about these quality processes I think need to be answered properly. Christoph is a...
So yeah, students complain that there are too many papers to write. We complain that there are too many papers to review, that we cannot read everything. So could we be more selective? I'm sorry. I said a bad word, but maybe a solution is to find a way. I'm not saying how to be more selective, but find a way to bring some papers out of the pack. That would be the interesting paper that would guarantee your career, so that student wouldn't have to write 10 papers for a PhD. I remember when I was a student, what SIGCOMM' paper you had a job, okay? I mean, probably now it's more. And so should we be more selective thanks to artifacts, thanks to other things? But remember, we're all volunteer. Yeah. And we tried artifact at IMC. Nobody has time. Okay? You cannot review the artifacts, and you can cheat the artifacts too. So the problem is how can we, it would be in the benefit of everyone. Your credit techniques where you limit the number of papers you can publish is interesting. It would not improve quality, but at least it would reduce the reviewing work. Another thing is when you have 3 deadlines in the conference, you have 3 TPCs, not 1. It's more work. So the community inflates artificially the amount of work that we have to do, and we reach the situation where people have to write many papers, we cannot read all of them. Is there something to do there?
Okay, so I sympathize with your issues, and I don't know exactly the solution, but at the same time, I think we have a mechanism, and that is there are tons of places where you can publish. You always find a place to publish your paper, whatever quality it is. And the only thing has happened is that we start at the top. We try to get it into whatever, the top conference. Once or twice, 3 times. And if it doesn't work, we go down the tree. Ultimately, you get it published, so you have a publication. So that's sort of a process that still is there.
You used to modify your paper between submissions. Okay? You try to improve your paper between submissions. Today, 2 days after you get rejected, you have a new deadline. Yeah. and so on. And I've seen paper which people would just resubmit. They don't modify it because they know it's going to go through at some point.
Okay, I think we're kind of pretty much out of time there, and I know Christoph actually has to get up to another session in 3 minutes, which is 3 floors up. Oh, okay. Okay, well, has anyone got any other angles they have on this? Because I think, okay, cool. I was going to add that the original model for universities in the academic world was Humboldt in Germany, where you have research and teaching. And actually having a lot of people doing the same thing is part of what you do when you teach, because you're teaching stuff you hope is right, and the students get to practice that, and they do things, sometimes writing papers. So we don't want to eliminate that, even though there's a large amount of replication. In fact, it's a good thing there's lots of replication going on. So that's not a negative thing there. It's just, do we want that to go through the same process as the new thing? It's like, do you want those channels to be for communicating stuff to be the same? And it could be we have, a new place, which is not just put it in an archive. It's something where there is some peer review. It is like, oh, you've done that paper again, and you reproduce the results, which is, but it's not in an ACM or IEEE or other high-level conference. I think that would be cool. By the way, Higgs, who did the standard model for, for particles, got a Nobel Prize. He only, I think, wrote 3 papers in his life. So that's pretty impressive. But so, yeah.
Yeah, so there are a couple of points here. First of all, the problem that is being presented here is indeed general for all sciences, and coming from architecture community, I can tell you that the problem there is just as bad, and in systems, of course, and security and everywhere. And for some unclear reason to me, the communities try to reinvent the wheel every now and then, more or less independently, without any communication between. Maybe the PC chairs that happen to be on both communities happen to be implementing similar policies, but there's no coordination. And it is actually a very weird situation to me. I believe that this is one part of the solution that should be considered at the ACM level, possibly. So that's number one. Number two, I think that the real problem is that there is a vicious cycle where because of the large load on the program committee, the quality of the review drops. It becomes more random, the acceptance, and the quality of the paper drops together. And so basically the most important, I would say the most important resource today is the reviewer's time. And because the number of expert reviewers that we can actually hire in PCs is not growing at the same rate as the number of submissions, we run out of reviewers. And when we run out of expert reviewers, the reviews get really random. And at this point, basically, the system gets broken. So my only suggestion is that we need to kind of make sure that there is a congestion control on the reviewer's time, meaning that we need to make the first selection rounds very, very lightweight, basically abstract-based, okay? And then after we do that, we can have a much more selective system with much lower acceptance rate. I agree that this is not great, but then the system will just simply rebalance, and the lower tier conferences will get more submissions because people realize that, submitting crappy work will not pay off, and unfortunately there will be quite a few false positives or negatives and early rejections, and it's really bad. But this is the only way we can keep the system operational, because the reviewers will actually do their job properly, because they will have time to read your papers, and surprise, surprise, it will not be LLM automatic filters. These will be humans who are actually reading and understanding what you wrote. So this is a rare and very, very scarce resource. So let's just, respect our reviewers.
Thanks, that's a brilliant point. Really good.
Can you, okay. No, it's just to pick up on something that he said, because this is a very interesting topic and it's very attractive. And tomorrow we're gonna have a non-paper session about this time, about AI credibility in networking. And one of the things that we would like to address to is how can we reuse things that people are doing in other sciences, because I'm just picking up on what he said, that we are always sometimes trying to reinvent the wheel, and people are looking at some of these problems in different areas too, that maybe we can learn something on that. Okay, so tomorrow, 4:30.
Just a quick idea. I love what you said. Instead of hot crap, why don't we have an additional tool that will summarize papers to 2 pages, and we review the 2 pages, and we just do elimination. People have to submit to hotcrap++ that will summarize the paper with LLMs, 2-page. I mean, I agree that, I mean, what you describe is totally true, okay? Okay.
So I've got the, I did have a summary. I don't think we've got time for that because I don't want to run into the next session. I just ask that we all join to thank John providing context and for the others to contributing in their fashion, and thank you all.